Okay, great. Yeah, I'd like to welcome Dr. John Licato, who is a PhD and an associate professor of computer science and engineering at the University of South Florida, director of their advanced machine and human reasoning lab, and founder of AI startup Actualization AI. Without further ado, I'll let you take it away, Dr. Licato.
Thanks, Halo. Can you all hear me okay?
Yes.
Yes.
Okay, great. Well, hi everybody. Thanks for having me. Yeah, we're here in Tampa, Florida. We kind of a interesting time here in Tampa. At my house we just got power back about 24 hours ago, so we're all still kind of out of sorts, I guess. But I'm excited to be here. I have kind of multiple hats that I'm wearing here, right? We got my research lab, but the ideas that I'm gonna talk about here are things that we just sort of uh, converted into a commercializable idea, and we just got an NSF SBIR to work on that. That's through the company Actualization AI. So I'm not going to be very heavy on technical details here, but I can expand on anything if there are any questions. Uh, so, as I don't need to tell you guys, but there's a lot being said about this term AI, and I usually start by clarifying what I mean when I'm actually using the term AI, because often in the midst of the current hype wave, we're hearing a lot of people saying things like, "Oh, AI can do this and AI can do that," and sometimes they'll go and make claims like, "Well, I used ChatGPT and it wasn't able to do something, therefore AI can't do something," right? And I think most of the people in this talk probably already know, but when we refer to AI, we are usually talking about the broader sense of AI, of which ChatGPT is just a tiny part, right? In fact, it's a product based on a tiny part of AI. But that's generally the area in which I'm comfortable with, this intersection between LLMs and generative AI, and under which ChatGPT rests. And usually when I give this talk to just people who aren't as familiar with the technologies underlying the advances in AI and the current drivers of the hype wave, they're not aware of the potential of hallucination, right? So they they think that just because the AI sounds confident, then it probably is correct. And we know that no, they're because of the way they're trained, they're optimized to generate the text that, fits their probability distribution that they learned from the data, rather than being optimized towards generating facts that are correct or verifiable and so on. And there's little tricks to reduce the harm of that, but for the most part, the underlying problem is still there. We know that one of the most highly discussed cases, people still bring this one up to me. This was a couple months after ChatGPT came out, and it was just some lawyers, right? They had ChatGPT do their work for them. It made up some citations. They didn't check their work. They turned it in. They got in trouble, right? And they used this term. They said, "Well, I heard that it was this new site, and I falsely assumed it was like a super search engine," right? And we know that it's not a search engine, although current versions of these large language model products can integrate with search engines. They are not search engines. And they got in trouble. They had to pay $5,000 fines. But it's this domain that I want to focus on, this particular domain of using large language models for reasoning about rules, which could be in legalese, like we see in laws, or it could be the kind of text that we see in regulations, contracts, codes of ethics, right? Informal agreements between people. Um, those are subject to hallucination, just like any other area in which large language models are being deployed. There are some pretty plausible arguments for why hallucination is inevitable, something that, even though we'll be able to reduce the frequency of them, and we might be able to reduce their harm, they are going to be something that is just a natural consequence of a finite entity with limited capacity for memory, with limits on how much computational time it can devote to solving a problem, limits on how much information it has access to, right? These very real limits make it so that hallucination is something that we have to accept is always going to be possible. And particularly in the legal domain, where, for example, these Stanford researchers investigated some claims that RAG was sufficient to get rid of hallucination, right? And I'm still hearing this, by the way. I've been to a couple keynote talks recently where the keynote speakers are just saying, well, we don't need to worry about hallucination anymore because RAG solves all of that, right? And I have to tell them, no, no, no. It's even if the source material provided to a retrieval augmented generation system is entirely 100% correct, hallucination is still possible. And that can be disastrous in cases where you have to reason about laws and regulations and so on. It would be great if we had a solution to that, because the dream is that we would have something like this, where we have some large complex rule set, right? It could be the United States tax code, or it could be just I don't know, the rules for some board game, right? And if we wanted to ask some query about it, whether or not some action is permitted according to these rules, it would be great if we could just feed that into some system, which might be LLM based. And if the answer is yes, we want it to tell us that the action is allowed, but we also want it to tell us why it's allowed, specifically what it is about the rules that permit that action. And if the answer is no, we don't want it to just say no. Think about an administrator in your company. If you ask them whether or not you can do something and they just say no, right? That's not very satisfying. It's more helpful if they say, no, you're not allowed to do that, but I understand what you were trying to do, and here's what you can do that's closely related to it. So, that's you get this idea of a someone who understands the rules that's actually trying to be helpful rather than someone that just says yes or no, right? The ability to do that requires a deep understanding of the rules that are constraining the behavior. The applicability of this kind of thing is tremendous, right? We can use it for getting tax advice, for navigating real estate laws, contract analysis, so on, finding loopholes in agreements, right? Finding loopholes in laws and company policies, compliance detection, knowing whether or not some piece of code written in a compliance sensitive domain like finance or healthcare is compliant with the many changing regulations that govern it. The applications of this are significant, right? So why don't we have this? Because if we look at the current state of the best I'm going to use reasoning loosely here. The best reasoning chatbots that we have, they still make amazing mistakes, right? So there's this high profile case where New York City put out a chatbot on their website, and they said that they would use it to answer questions about New York City laws and regulations, right? Not a simple domain to understand. And unsurprisingly, it made a lot of clear mistakes almost immediately were discovered after it went up. It was saying that, our buildings required to accept Section 8 vouchers. It said, no, they're not required to. That's blatantly wrong. They are absolutely required to. Can I take a cut of my workers' tips? The chatbot said, yes, you can do that. No, they can't, right? And so on. It gave, I think someone else posted something on Twitter where they said, you know, uh, can a tenant get in trouble if they set the building on fire? And they said, no, no, that's totally fine. It's totally okay and cool to do, right? So we still have these sorts of mistakes that the chatbots make when they're reasoning about laws and regulations. And we want to know why that's the case, right? Because if we have artificially intelligent systems that are increasingly going to interact with us in our daily lives and are increasingly going to be delegated responsibilities and decision-making capabilities, we want to make sure they can actually follow our rules, right? And we want to make sure that we can understand the rules that they actually are following. So why is it so difficult? Well, in the real world, the actual legislative systems that constrain our behaviors have a bunch of properties that make them particularly difficult to manage. They're highly referential. They have this sort of spaghetti code property, right? If you guys remember from the QBasic days, and when you have code that refers, go to line 10 and all this stuff, right? Law is often like that. It'll say this section, refer to this section for this, and definition in another section, and so on. Um, they are very large. If you imagine the size of the U.S. federal tax code, right? That's quite a lot to squeeze into one prompt. Even the biggest LLMs don't have prompts nearly that big. You can again abrogate some of that with retrieval augmented generation, but it doesn't exactly solve the problem 100%. And then there's these tricks that we use in processing large language models where, sometimes we do a little bit of compression of the text that you have to reason over. Um, and that kind of distorts the meaning a little bit, summarizes it. But those details especially matter in the legal domain. The specific word you use to express some sentence is going to can make a crucial difference. The fourth thing is that there's this property of defeasibility. So if I look at rules A and B and using only those rules, I can conclude that something is allowed or not allowed, legal or illegal. Uh, there might be another rule that overrides those two rules that cannot be understood without looking at that rule that's separate from the two, right? So in other words, if you look at the subset of the rules, that whatever conclusion you draw from that might be insufficient unless you examine the entire set of rules that are actually relevant. And finally, there's this problem of open-texturedness, which I'm gonna focus on and which I've been doing talking a lot about in my work. So open-texturedness is this concept that comes from philosophy of law, and it's most famously described by philosopher of law H.L.A. Hart. I think it's generally credited to Frederick Weissman, who was a philosopher, member of the Vienna Circle, for those of you who are connoisseurs. And it's this idea defined this way that, when you have an expression expressed using natural language, an empirical predicate is what we usually delineate. There always remains a set of possibly remote possibilities under which there would be no right answer to the question of whether it applies. Okay, so best way to illustrate this is an example. So you have this rule, no vehicles allowed in the park, right? Seemed pretty straightforward. If you had a robot that was standing at the gate to a park and it had to guard who gets to go in, and told it to enforce this rule, seems like it should be pretty straightforward, right? But we can easily think of borderline cases. So someone comes by with a driving lawnmower, right? Does that count as a vehicle? Maybe, maybe not, right? A little kid comes by with a remote control car. Does that count as a vehicle, right? Um, so you might say, well, okay, only things that have engines with above a certain size. So then an emergency vehicle comes by, the ambulance wants to get into the park, right? Should that be allowed? Probably, right? But how is that consistent with your understanding of the rule? When should you make exceptions? And we can think of answers to all those questions, by the way. We can say, oh, okay, this is why I would allow the ambulance, and this is why I wouldn't allow a monster truck, right? And so on. But how do you come up with those exceptions, right? What kind of background knowledge do you need in order to reliably come up, reason about potential border cases in such a way that can be defensible, in such a way that if you have to explain your decision later to a bunch of other human beings, then how do you actually make sure that your judgment is going to be something that has uh, is good at the time that you make that decision, right? So this The open texture term here is vehicles, right? What exactly do we mean by vehicles? And it's an open texture term. And law, human law, and by which I mean rules, commands, regulations, again, all of that, policies are chock full of open texture terms. They're all over the place. And it is not something that is going to go away. It's something that lawyers and judges they build their entire careers on how to properly interpret open texture terms. Computer scientists do not. This is not our area of expertise, right? Open textureness is not something that's going to go away. It is a feature, not a bug. So, a lot has been said about how um, we need that flexibility that open textureness provides in order to make law work the way it does. When you're defining the rule at the point at which you write the rule, you can't fully enumerate all possible conditions to which this rule will be applied. There's just, law is not meant to be that inflexible. And so there are ways to mitigate the effects of open textureness. We can obviously, when we're writing rules, we can say, okay, let's try to examine ways in which this rule might be misunderstood, right? And then try to rephrase the rule so that it avoids some of that ambiguity and possible misinterpretation. And that's, of course, something we have to do. And that's something that's gonna that we do, we do it as programmers, right? But that's never going to get rid of open texturedness entirely, again, because it's a feature, not a bug. Open texturedness also allows for a delegation of decision-making responsibility to the people who are actually going to be on the ground when the rule is applied. So in other words, Washington creates some rules, but they have to allow a certain amount of ambiguity so that the people who actually are enforcing those rules can make judgment calls, right? So again, feature not a bug, right? Open textureness is not something that's going to go away. It's something that we actually want to a certain extent. So the point that I'm trying to make here is that open textureness has to be embraced. It's something that we do try to minimize, but we do also need to accept that it's going to exist, and therefore our AI agents need to be able to reason about open textureness in a way that can be defended and a way that can be aligned with the way that humans reason about open textureness. So how do we reason about open textureness? I've argued about this in a couple papers, but one of the ideas is that we use this thing called interpretive reasoning. And there's a lot being written about this again in philosophy of law, and there's a whole body of researchers in the intersection of AI and law. But a point that I've tried to make, and I won't read this all to you here. There's papers that I can point you to if you're interested. Is that an interpretive argument is an argument that is used in support of one interpretation of a rule. Okay. So the general form of an interpretive argument looks like this. This is from Sartor et al. 2014. You have an expression that occurs in a document. So E is the open texture term. You have some setting in which you're interpreting that expression, and you say that E would fit that setting using some particular interpretation. Therefore, E ought to be interpreted that way. And there have been attempts to categorize or catalog the types of interpretive reasoning or interpretive arguments that are used. So this landmark paper from 1991, McCormick and Summers, they had this they did a multi-country analysis of legal systems, and they found that these interpretive arguments are seem to appear all over the place. The relative importance and persuasiveness of each one of these argument types differs from culture to culture, but these arguments still seem to appear. And you have arguments like argument from ordinary meaning. So you say, well, the term vehicle should be interpreted as just anything that goes vroom vroom and has a motor, because that's what the normal person would think, right? That's the ordinary meaning argument. You also have technical meaning. You say, well, the definition of a vehicle is that it has four wheels and it's self-propelled, right? So therefore, you can delineate what is and isn't a vehicle based on that, right? Then you've got precedent. You say, well, before when the human enforced this rule, they let the emergency vehicle in. Therefore, I should let that in. I should let the emergency vehicle in now, right? And so on. You can imagine how I'm sure you can think of other arguments for why or why not a certain thing should be considered a vehicle. But the point is that there are these common types of arguments that are given in support or against particular interpretations of open textured terms. And what we do when we're trying to, or what we should do, where I'm talking normatively here rather than descriptively, what we should do when we're evaluating whether one interpretation is correct or not is evaluate the interpretive arguments that can be given for and against some particular interpretation, right? So I'll give you an example. Classic example from iRobot, right? From Asimov. You got these three laws of robotics, and then there was a lot of confusion about this first rule. A robot may not injure a human being or through an action allow a human being to come to harm. So the basic idea of one of the stories is that these are the rules that the robots have to follow. The robot realizes that, if I don't imprison all humans and subjugate them under my command, then I'm going to allow them to hurt themselves, which qualifies as allowing harm through inaction. Therefore, I am required by my rules to imprison them and be in control of humanity, right? Reasonable interpretation. But that is a classic misinterpretation of this rule. Why is a misinterpretation? There are arguments that can be given in support of the idea that, yeah, enslaving humanity is a legitimate interpretation of this, but there are other arguments that it is not a good interpretation of that rule. So what we want is an account and a way of evaluating arguments that makes it so that the don't enslave humanity interpretation is the one that wins out. And one way that we could do that is simply list the strongest arguments for and against some particular interpretation using the framework provided by interpretive arguments. So we say, okay, argument from larger purpose. If I ensure humanity no longer has any control over itself, then it's going to prevent a lot of harm. So that's a argument for enslaving humanity, right? Argument from technical meaning. Argument from precedent would be a significant one here. Prior attempts at world conquest were considered actually causing harm, which is not what we want to do. So therefore, I shouldn't enslave humanity, right? And you can come up with arguments for and against. And what we need is some way to compare this set of arguments, assign them some sort of strength, some sort of persuasiveness, right? A lot of this is going to depend on who your intended audience is when you evaluate these arguments. And we want to make sure that whatever evaluation mechanism is used to compare these arguments is one that would align with the values of your stakeholders. In this case, the human beings that are going to be potentially enslaved by this robot's actions. Okay, so what can we do with this idea? We can say that, well, try to formalize this a little bit and say that if you have AI that is going to be rule following, meaning that it is going to interpret and act in accordance with rules that potentially contain open textured predicates, open textured terms, right? If you have an AI like that, then it should be argument justified, meaning that its goal should be to act in accordance with interpretations that can be supported using the strongest set of arguments, the strongest set of possible interpretive arguments specifically. This is what we've been calling the minimum defeasible interpretive argument position. I'll explain more of that in a second. Notice the term argument justified here as opposed to explainable. This, some people can think of argument justified as a subcategory of explainable AI. But in the level of abstraction that I'm concerned with here, we don't care so much about why an AI, did what it did in the sense that we don't care about the neuron firings and the weight balances and all of that, right? Of the neurons. We care about what are the arguments that it evaluated. What is the strongest justification that can be provided for the course of action that it chose, the strongest course of action against it, and how were those two possible alternatives evaluated and compared? So the obvious question here is, all right, so what's a good argument, right? Isn't argumentation all subjective? Isn't it, everybody has their own views and everybody has their own values and every position is equal, right? How can we actually assign numbers to this so that decisions can be actually made in the heat of the moment, right? And what algorithms can we use to find this? And there is actually a very active area of work in answering this question. So this is a photo, this is a figure from an image from a 2017 paper, Wachsmuth et al., Helmut Wachsmuth's paper. Um, and, this categorizes a whole bunch of different approaches to formalizing argument strength, right? So they break it down into three different types: reasonableness, cogency, and effectiveness. And each of those can be broken down into different measures of argument strength, each of which have been tied to, you know, data sets and algorithms and regression algorithms to actually uh, assign numbers to these things, right? Different scales and so on. And so we can make some combination of all these approaches. And this is 2017, so this has expanded quite a bit since then. I got to update this figure. But the point is that there is quite a bit of work in the literature trying to categorize and formalize all the different notions of argument strength, and so that we can actually decide which of them are most important to us in some particular domain. But the notion of argument strength that I prefer is something that we call minimal defeasibility. And it goes like this, okay? Uh, let's say that we're asking the question, do fish feel pain, right? Do fish feel pain? Think about your answer to that question, okay? And one argument that might come out, or one interpretation of the term pain, would be, no, they don't feel pain because they don't have nociceptors, right? Nociceptors are apparently some neural connection that allow for the transmission of pain signals or something like that. Okay. Now, all right, that's one argument against, but then you might say, no, no, that's a bad argument because actually there is at least one species of fish that does have a type of nociceptors. And then you say, okay, well, most fish don't feel pain because most fish don't have nociceptors. And then you can counter that. You can attack it and say, well, actually, most fish do have a type of nociceptors, specifically C fibers. And then you can respond to that and say, all right, most fish don't feel pain because it's not only about the nociceptors, it's about the entire physiological system that causes the signal transmission and the processing of it, and the neocortex to understand the sensation of pain and associate it with negative sentiment and suffering, right? You can say that it's more of a pain is more of a complex phenomenological construct that doesn't exist in fish, right? And so on, right? So you see the pattern that's going on here. Someone gives an argument, that argument is attacked, the argument is then adjusted in order to accommodate that attack, then another attack can be made, and then the argument is adjusted, and so on. And this is a common structure that we see in argumentative discussions, right? What's happening as this dialogue continues is that the argument is going in the direction of what we call decreasing defeasibility, meaning that as we go further down in this list, the strength of the argument increases in the sense that it's more resistant to counter arguments, right? After a while, the amount of counter arguments you can levy against it are going to be very nitpicky, right? Very, very borderline things. And the argument itself is going to be very, very resistant to significant knockdown counter arguments. But also, the argument kind of becomes weaker as you go down that list because the generalizability of the argument decreases. Because if you look at the first one, we're saying, no, fish don't feel pain ever, right? Because they don't have these fibers. But then by the time we get to the end, it's, well, most fish don't feel pain because of this condition and that condition. And, we got a lot of weasel words in there, right? A lot of qualifiers. And so the generalizability of the argument decreases, which is okay because we get more accuracy there, more interpretability, less subjectivity to open texturedness and the sorts of misinterpretations and inconsistent interpretations that open texturedness engenders. Okay. So again, what's going on in this direction is in the down direction here is that defeasibility is decreasing. And the notion of argument strength that I like to use is this, is that we want defeasibility to decrease over time. And the strongest argument is the one that has the lowest defeasibility. Okay. So we can define it and say that an argument is minimally defeasible if and only if it's maximally resistant to possible argumentative attacks. So this is just a description of what we mean again by minimally defeasible and a description of the position that says that if we have AI that we want to be rule following, then number one, it should use argument justification for its conclusions. We don't care necessarily about the causal explanation for why it reached the conclusion it did. We care more about about the full argument graph that's given to support its final conclusion, its final recommendation. That's argument justified AI rather than explainable AI. And number two, the notion of argument strength that we should target is minimal defeasibility. We want it to be maximally resistant to strong defeating counter arguments. And finally, when it actually acts, it should do so in accordance with the conclusion that it was able to come up with that is minimally defeasible and argument justifiable. Okay, so this is just on the bottom here, we have an illustration of what an argument graph looks like. Again, in the AI and argumentation literature, there's a whole bunch of work on different ways to represent how arguments interact with each other, right? One strength of requiring this complex output is that it allows for it makes it more difficult to use rhetorical flourishes, right? So I'm sure you've seen this trick where high-level administrators or politicians, or sometimes they'll do this thing where, well, they'll say, okay, X is the action we should go with, and then they'll only present arguments in favor of their position, and then they will maybe give some counter arguments, but they'll give really weak ones that are easy to knock down, right? The old straw man strategy. Forcing an argument graph like this makes it more difficult to hide strong counter arguments. It makes it so that you have to show how arguments interact with each other and which arguments were actually considered and counter arguments were considered. So it introduces a level of transparency in the argument justification process that, again, there's a lot of work on different ways to represent these graphs. And yeah. Okay, so a few minutes left. I want to just kind of briefly summarize some work that we've done in this direction. One of the things that we did a couple years ago in 2019 was we explored open texturedness by first what we did is we took a bunch of professional organizations, so like the American Nurses Association, the American Architects Association, right? And we found their codes of ethics. And we selected some rules from those codes of ethics. The reasoning there being that codes of ethics have a lot of open textured terms in them, right? Imagine the rule, you need to act in a way that's for the good of humanity, right? What does the good of humanity mean? That's a very, very open textured term. Or you'll see rules like you need to behave in a way that's reasonable, right? What does reasonable mean? Okay. So we took some rules from these codes of conducts or codes of ethics for professional organizations, identified open texture terms in them, and then we asked participants, hey, give me an instance of a scenario that is a clear instance of this term, or a clear non-instance, or an ambiguous instance of this term. And then we asked a second set of participants to assess, does the scenario given align with the term? And then provide a justification of your rating. So that allows us to get a textual justification, which is an interpretive argument, and then a rating of the strength or the confidence of that justification. And this is a really nice little data set. It gives us a set of open texture terms. It gives us interpretive arguments. It gives us scenarios that are either clear instances, non-instances, or ambiguous instances of those open texture terms. And we can do a bunch of analysis with these. Um, so yeah, it's a relatively small data set, a lot of manually curated things, but it was enough for us to expand on. So this is an instance of one of the elements in our data set about the Code of Ethics for the American Institute for Architects. And this describes, you know, the phrase is making public statements, and the scenario is you have an architect who posts a Facebook comment criticizing a design for a controversial new building, right? Does that count as a public statement? Some people say absolutely it does. And their assessment here was yes, because it's in public view. But the point is that we have a nice little interpretive argument here that we can then analyze. And so a couple years later, what we did was turn that into a game called Aporia. And what this game does is it gives you one of those open textured rules. So you see in the top left here, professional economic developers shall carry out their responsibilities in a manner to bring respect to the profession, right? And then we have one of the ambiguous scenarios that were given to us. An economic developer decided to have a residential community rezoned to include commercial businesses, basing it on a survey given 5 years ago. Does that count as them following the rule? And what happens is two players have to argue against each other. One of them says, yes, it follows the rule. One of them says it does not follow the rule. And they have to give arguments back and forth. And we, again, use that to create a data set. So now we have a data set of interpretive arguments being given back and forth. And we also have a third player as a human judge who has to decide which player was the winner based on who gave the more persuasive arguments, right? Um, and that allows us to also have a data set of what's sometimes called meta-interpretive arguments, right? The arguments for why one interpretive argument is better than another. And so this game is publicly available, and we have a paper talking about this. One thing that we have also done is explore the extent to which you can actually formalize rules that have open texture predicates. The basic idea here is that open texturedness, remember, is a feature, not a bug. It's something that's never going to go away entirely, and something that we don't actually want to go away entirely. But although you can never fully formalize the rule, that doesn't mean that you can't fully formalize an interpretation of the rule. And this is what we call the interpretation as code interpretation. The idea that although the rule itself needs to have that certain flexibility, an AI interpreting that rule can explain how it's interpreting the rule using something fully formalizable like code. And here's an example of that. So you have the law, no vehicles allowed in the park, right? If we ask the AI to write a function explaining what your interpretation of this rule is, right? Then we can actually have its reasoning in a form that we can inspect. So we can see two possible interpretations here. One is a function that determines what that assesses whether or not something counts as a vehicle under this rule. And this one on the bottom left just says, well, if it's a motor with a weight above a certain amount, then no, it's not allowed. Otherwise, it is allowed. Okay, now not a very robust interpretation, but the point is it is a interpretation, that we can now inspect and critique or fix or what have you, right? And on the right, we have an alternate interpretation that's a little more sophisticated. We did this with a board game, and we some other work that I'm just going to point to start concluding. I did some work with the uh, uh, Air Force for this what's called Summer Faculty Fellowship. Did that for the past 3 years, and they've been very excited about board games over there. A bunch of gamers and guys who are just having fun playing board games and calling it research, right? So we spent one summer pretty much playing Magic the Gathering the whole time and using it as an exploration for this idea of open texturedness. If any of you are familiar with games like Magic the Gathering, they have these card effects, this text on them that describe certain effects, right? And sometimes there is ambiguity and disagreement about what that text actually means, and we can actually examine those data sets in order to, you know, test some of our ideas about open texturedness. And we wrote a paper on that a couple years ago. We also did it with complex warfare styled board games like Next War Taiwan. That's when we did some work in the interpretation as code approach that I described in the previous slide. And with my company, right now we're working on using this idea of interpretation as code and interpretive arguments to ensure that chatbots or AI agents actually follow the rules that they're given. In other words, you have human rules with open texturedness. How can you have some assurance ahead of time they're actually going to follow those rules? That's what we just got the SBIR funding to work on. Okay, and with that, I think I left some time for questions. So thank you all very much for the invite again, and happy to answer any questions.
Great. Thank you so much, John. That was a fantastic talk. We already have one question in chat from Jan Krasny. So we can start with that. Their question is, my question to you is if you think that this interpretable openness is more problematic in Anglo-Saxon law than in continental law, or is it present regardless of the law? I am asking as in the Europe, the law is embedded in the judicial praxis.
Yeah, that's a great question. It's a great question. So my understanding of the differences is that interpretive arguments will still take place, but the persuasiveness of different types of interpretive arguments differ from culture to culture. So, for example, when I was in grad school, I did a lot of study focus on analogical reasoning, and in the United States and UK traditions. Um, you can use analogies to make sense of the law, right? But in Germany, the legal systems were such that you can't, analogies are basically disregarded there, right? They're saying, no, you're just drawing an analogy, but you have to take a very literal interpretation of the law, right? So open texturedness still exists, but the ways that open texturedness is resolved differs. But it's still going to be there, right? The basic idea is that there is whether the basic idea is that there is some flexibility that is built into the law so that the people writing the law don't have to make all of the decisions at the time of writing, right? So that some of the decision making can be made by the people who have to enforce and follow the laws. That exists whether or not the source of ambiguity is the language itself. I think maybe I focus a lot on the language, maybe because that's what I'm interested in. I like the properties of language and ambiguity there. But even if there's a legal system that does not place a heavy reliance on how the rule is stated, the basic property where ambiguity exists in the rules is still going to be there.
That makes sense. If there's any more questions, feel free to add it in the Q&A or unmute yourself if you're on the panel. Yeah, go ahead, Christina.
Thanks, actually. I don't know much about a legal area, but this was very fascinating talk. But, I mean, so I understand your point is basically to automate basically reasoning about human behavior to make it easier for people to abide by laws and everything. But my question is actually, what have you considered kind of what are the potential downsides of this kind of automation of human behavior? So, for example, I'm going to just go out and propose one potential downside, wonder what you think about it. So any kind of formal system of rules risks basically kind of maybe falling under kind of Gödel's incompleteness theorem, where there could be some valid behaviors which are not going to be allowed within the system, not going to be reasonable in the system. So this kind of, so I'm worried about, once a rush to automate might over-constrain behaviors too much. So just want to get your, like you can respond to this, or maybe think about some other things that worry you, potential downsides of this kind of automation.
Yeah, I agree actually. So and just to clarify, I don't think that there should be a rush to give decision-making capability to the AI agents, especially when hallucination is still such a real problem that we're all very familiar with, right? But what I'm seeing is that decision-making responsibility is already and is going to be given to these agents. So the idea is that if it's going to happen anyway, we want to minimize the impacts of it. And one way to do that is to say, look, okay, fine. If you're gonna give it some decision-making autonomy, go ahead. But make sure that you require these systems to justify the decisions that they make so that we can inspect it, and so that if they make a decision that's wrong and someone asks why, you're not going to come to me and say, well, because the weights of the neural network were such, no, I want you to make it so that the system is explicitly considering human understandable arguments so that we can actually communicate with each other about how to, properly ameliorate it. But I don't think that necessarily would be sufficient either. I don't think that would justify a rush to, therefore make AI be our judges and take over our legal systems.
Yeah, or just like interact with facilitate human interactions. I'm just worried about over constraining. But thank you. That sounds reasonable.
Yeah, I agree completely. Yeah.
We have another question from Adam Russell. He asks, what might the end of Chevron deference mean for this approach?
Oh, yeah. Okay, so for those who aren't familiar, so the Chevron doctrine was this I guess tradition in U.S. law where a lot of if there's confusion about how some particular law should be interpreted, right? Then we give a lot of deference to the administrative organization, the EPA or whatever, right? And we say that whatever their interpretation is, judges are going to give them a lot of deference to determine what that interpretation should be, right? Whether it so essentially the current Supreme Court said, that's not a thing anymore, right? Chevron doctrine no longer exists. It's judges that have to decide what the interpretation of laws are, and also, of course, the people writing the laws have to clarify that in the legal code itself, right? It's fine. It shifts the burden of who. Oh, okay. So I'll say this. It makes it so that those of us here on the ground, right, when we're trying to figure out what the correct interpretation of a law is, instead of looking toward the agency, now we got to look toward, what is the judge going to rule on this, right? So it shifts where we need to look to determine what the proper interpretation is. And that's exactly why I think it's so important to acknowledge the difficulty in interpreting open texturedness for AI, right? Because if we programmed and trained our AI systems on the writings of the administrative agencies, and all of a sudden now the underlying law has changed, so now that's no longer the source of correct interpretation, what are we going to do? We got to retrain all of our AI all over again, right? It's better if we require them to explain why they make their decisions using arguments so that we can look at that argument graph and see, oh no, you're relying on agency deference here, which is no longer how we make this decision anymore, right? We need to have that sort of flexibility.
That makes sense. Thanks for answering that. We have another question again from Jan Krasny asking, is it maybe better if the AI legal assistant could flag the problematic open elements of the text? Would that be a way to go around the AI hallucination?
Yeah. So you know, yeah, I had a slide on this, but the idea here is that attacking open texturedness and the problems is a two-prong approach, right? Like there's one approach where we want to reduce the open texturedness, and that could be, like you described, we have something that flags potential open texturedness and finds potential problems with it and tries to find loopholes, right? And then you change the phrasing so that it reduces that. And actually, that's some of what we're doing with my company. But open tech, even that is going to be insufficient. And that's the reason is because open texturedness is never going to go away entirely. It's just how language works. It's just how delegation of responsibility works in human systems. And we don't really want it to go away because I don't know what the replacement is. Just programming code, right? Which might be kind of cool. There's this whole thing about smart contracts a couple years ago, right, with the um, cryptocurrency boom. But open texturedness has some desirable properties that are, yeah, things we want and things that even if we want them to go away are not going to go away.
Great. These are all great questions. But again, feel free to keep them coming. Another question, can you talk a little bit more about just like the work in Magic the Gathering? Like I'm especially curious if there's like any findings of like how it compares to like how humans would interpret it, or even just kind of
Yeah.
like are more powerful cards typically harder to interpret?
Yeah, yeah. So what we did there was we essentially tried to figure out how we could turn so we wanted to you get the text on the cards, right? The effect text. And we wanted to figure out how can we turn that effect text into functions, into programming code that most faithfully represents the effect text, right? And I know that kind of goes against what I said that it can't be formalized in the first place, right? But it was just an exploratory paper anyway. And what we found was there's quite a few data sets on whenever people have disagreements about how some text should be interpreted, they have they basically have a mini legislative process, uh, I guess a judicial process where you have a judge come in. Um, they have I forget what the ranks are called now, but they have these certifications that you can get so that you're qualified now to make rulings on Magic the Gathering conflicts, and you know and you can they actually show the rulings that these judges make, and they say, well, this interpretation is consistent with these previous interpretations from 5 years ago, and then that gets stored in the database. And so you have this microcosm of a legal system where you can actually see how interpretations change over time and how certain personalities influence those interpretations, right? It's a really, really fun thing to look at.
That's super interesting. Thanks for answering that. Any other questions from the people in the panel?
Yeah, so actually, one thing that we started doing last time was, and one thing we're proposing actually for current work is there's these things that the military was interested in called they call them matrix games, which is an unfortunate name because it has nothing to do with the matrix. It's not very Googleable, but it's got the same structure as a Dungeons and Dragons game, right? Where you have a dungeon master essentially who creates the environment, and then someone says, "Oh, okay, I'm gonna rescue the hostages by doing a misinformation campaign or something like that, right?" And then the job of the dungeon master is to say, okay, do you have enough money for that? And, you got to roll the die for this. And, you also have a domain expert, someone who's actually familiar with that area of warfare or whatever, and they have to say, no, you can't do that without this money, and you got to consider this factor. And, there actually are uh, projects in place where we're trying to figure out how to, you know, how do you enforce rules for this sort of game, and how do you come up with environments that can properly test the open texturedness in those rules in this sort of game? So there's a lot of really exciting possibilities there. We're just trying to figure out which DoD agency is actually willing to fund it.
That makes sense. For those not following, Adam in the chat said, solve arguments in D&D and I will be impressed.
Yeah.
Um, I guess just to wrap up, I'll ask one last question. For researchers interested in commercializing their technology, do you have any advice, or can you kind of talk a little bit to your story?
Sure. Yeah. Yeah, the university, I I really like the idea of thinking of your research projects as a pipeline, right? So like, you create the research and then turn it into a patent and then commercialize it and then go back to the research. And I'm a real big fan of that pipeline. And honestly, I'm still relatively new to it. This is my first startup that we're actually legitimately pursuing. But um, I wish I did it 3 years ago before the AI boom, but the second best time to do it is today, right? So yeah, I encourage people to get involved. Oh, another thing that I would say is, you get such a different perspective on your own ideas when you're on the research side of it, trying to get a paper published, and when you're actually trying to turn it into a working product, right? You get such I'm learning so much about the limits of my own ideas when I'm doing the latter. So I strongly encourage everybody doing that.
That makes sense. Well, thank you so much, Dr. Licato, for coming and fantastic presentation. Thank you for your
Awesome.
time.
Thank you all very much.
Oh, actually, maybe one more question from Craig.
Actually, no, I meant to applaud because I really
Oh,
enjoyed the talk. I didn't have a question, but I really enjoyed the talk. It was a great talk.
thank you very much. Bye, everybody.